In this lecture, we will talk about how to calculate this quantity by using the function f of x equals 6x plus 4. We don't want to make things complicated, but we do need to understand why do we need to calculate that. Okay, because this is going to be used in the calculus. This is a linear function. Sometimes the graph may not be a linear function. For y equals f of x, this one, the graph might be a curve. Might be a curve as I draw it right here. This is the graph. So if x is here, then the height will be f of x. So this point will be x f of x. That's this point. Now, if you add h on x, then x plus h will be this point. Okay, on the x coordinate will be this point. And then correspondingly, the height is you plug in x plus h into the equation, into the function. That will be f of x plus h. So when x equals x plus h, the height is this one, which is f of x plus h. Okay, and then this coordinate will be x plus h for x, and the y coordinate will be f of x plus h, will be this one. This one. So basically, on the curve, from this point to this point, x goes how far? From here, horizontally, go from here to here. And then y goes how far? From this place, goes this high. Go this high. So basically, when x goes from x to x plus h, the increment is h, or we say run. X runs from left point to the right point. The amount of run is h. And then the rise is the difference between f of x plus h and f of x. So this one basically stands for rise from this point. Vertically, it goes from here to here. Horizontally, it goes from this point to this point. So this quantity basically is rise over run. Okay. Yeah. That's the meaning for this one. Now, in order to, right down here, the curve is not linear. But in order to make our case easier, here we use what? The exponent is 1. We use linear function. Sometimes here is 2 or 3. Then the exponent is bigger than 1, the calculation will be more complicated. Okay. Now, let's calculate f of x plus h. F of x plus h, one here is x, then here is x. One here is 1, here is 1. One here is 2, here is 2. When this place is x plus h, you want to do is replace this x with this quantity, x plus h, and then plus 4. Okay, so what we get is 6 times x, 6 has to time h, distributive property, plus 4. Now, then we got to calculate the difference. Basically, we want to calculate rise. Okay, so in this case, x plus h minus f of x equals what? F of x plus h is this one. So you just simply copy x, 6x plus 6h plus 4. Now, subtract f of x. Let me put subtract 6x plus 4. Yeah, that's f of x. So subtract the whole thing right here. Again, you got to use distributive property. If you don't use it, you're going to get a mistake. So 6x plus 6h plus 4 minus 6x minus 4. Negative goes to 4 also. And then you see what? 6x, positive 4, negative 4. They cancel each other. So things left over is just what? 6 over h. So basically this one again is what? Is rise. Now, then third one. Third one is we want to calculate rise over run. We know the rise is 6h, and we know the run is h, and then you know in front of h there is a 1. 1 times h is h. You cancel this h. What you get is 6 divided by 1, which is 6. So the rise of run is a constant. It's 6. We know this is a linear function. This is actually the slope. Okay. So that's basically, you know, even we don't calculate this one, we will know that eventually we'll get this 6, because rise over run for linear equation, this is the slope-intercept form, so we know the answer will be 6, will be the coefficient of this 6. But here is the curve. Again, the equation may not be linear. If it's linear, we know that will be this constant. Yeah. But here is not. It's not. Okay. Then again, in calculus, we need to calculate the rise over run when h gets smaller and smaller. If h is smaller, you know the distance between those two are very small, gets smaller and smaller. So this point is basically very close to x. Then you know when x plus h is very close to x, then this point will move from here very close to somewhere maybe here. Or maybe even tends to 0, so this point may close to this one. Then this intercept, this line is going to be moved when the point moves. This line moves, okay, like that. So eventually this line is going to be the tangent line of this curve at this point. So actually in calculus we will see that. Yeah, that's basically you choose the limit, let h goes to 0, and then you will get the slope of this tangent line at this point. That's in calculus. Okay, so please review this lecture. I'll see you next time.